Hello everyone. So welcome to a revision lesson of cubic functions. So after this section yama cubic functions sizothoma ukurevisa paper 2 and then sizoya ku analytical geometry and Euclidean geometry, right? So each section le yama cubic functions ngenye yama section inama marks amaningi ku paper 1. So if uzama ukuthi uyibambe, I believe ukuthi uzokusizeka lapho, right? So as a revision or as an introduction, I'll just read through the notes and then ngizozama ukuchaza as we read through, right? So so we have cubic polynomials, which is just cubic functions, right? The cubic polynomial is a function of the form f of x is equals to ax cubed plus bx squared plus cx plus c, and we can represent it with a graph, right? In order to draw the graph, we need to work out the characteristics of the graph, right? Just like any other graph, we'll need to calculate the coordinates of the x and y intercepts, any critical points such as the turning points also, right? So we can use the derivative to identify the slope of the graph at certain points. So our derivative, they come in handy kule section le when you need to calculate turning points with cubic function, right? So make sure ukuthi uyakwazi uku-apply ama-rules of differentiation, right? So yeah, we also need to know how to solve equations in the third degree so that we can work out the x and y intercepts, right? So the method that I prefer is to use a long division when I need to calculate x-intercepts, right? For y-intercept, it is easy. You just let x be 0 and your last term there, that constant, will be the y-intercept, right? So solving equations in the third degree, we're gonna use the Factor Theorem, and then after using the Factor Theorem, we will use the long division. But then if you prefer doing this using another method, that's fine. I just prefer a long division, right? So first things first, if maybe you need to factorize this equation here, x cubed minus x squared minus 5x minus 3, you'll need to use the Factor Theorem. So this is where you sort of like find one value which will make the whole equation to be 0, right? So the Factor Theorem states that if f of k is equals to 0, then x minus k is a factor of f of k, right? I think here it's supposed to say if f of k is equals to 0, then x minus k is a factor of f of x. So if f of x is equals to this, we want to find the x values that make f of x be 0, right? So here they sort of like use a method of trial and error to find one value that will make this equation to be 0, right? But then to sort of pick those correct those correct values, you need to look at your last term, that constant there, so and then look at the factors of that constant, right? Normally those factors are the ones which will sort of like give you a value which will make the whole equation to be 0. So here they use the constant minus 3, and then they have the factors of minus 3, which are minus 3, minus 1, 1, and 3. And then by trial and error, they pick one of these and see which one makes the equation of f of x to be 0, right? So for instance, if they say x equals to 3, and then you substitute minus 3 in your equation of f of x, you get minus 24. Therefore, that is not a factor because it doesn't satisfy the Factor Theorem, right? And then if x is equals to minus 1, then f of minus 1 is equals to 0. Therefore x plus 1 is a factor of f of x according to the factor theorem, right? So then we'll use the x plus 1 to find the other factors, right? So from this stage here, nasentole one of the factors, mina I will normally proceed in long division, right? So I'll just go straight to long division to find the other factors, right? So I'll sort of like do one example where I use long division, and then how to find my x-intercepts. Okay, and then you can also use synthetic division. Let's say ukuthi sengikhohle ukuthi isebenza njani, but then you can use any method oyipreferako, right? So maybe let us do this one as an example. F of x is equals to okay, let us do this as an example. So we'll need to find factors for this function, right? So suppose there's a question which says find the x-intercepts of f of x, right? So you will need to look for those values of x which will make this function to be 0, right? So meaning you will need to have you will need to sort of factorize this and then solve for x, right? So then by effector theorem we can pick one value which will make this equation to be 0, and then use that value or factor to find the other factors, right? So to find a value which will make this function to be 0, look at your constant and its factors. So look at your constant -3, and these are the factors of -3. You'll have -3, -1, 1, and 3, right? By trial and error, you can start here and see if you substitute -3 in your function, what do you get? So if I say f of -3, and then I just substitute -3 where I see x, I'll have okay, let me check in my calculator, -3 cubed minus -3 squared -5 -3 -3, you get -24, right? Which is not equals to 0. So x plus 3 is not a factor, right? Is not a factor, right? So we proceed to f of -1, right? So in my calculator where I see x, I just put -1. So I'll have -1 cubed minus -1 squared -5 -1 -3, and then you get it's 0, right? So because by factor theorem, if f of -1 is 0, x plus 1 is x plus 1 is a factor of f of x, right? So x plus 1 is a factor of f of x, right? So now I can use x plus 1 to find the other factors, right? So now I'll use long division, and I'll have x plus 1 as my divisor, and then here I'll have x cubed minus x squared minus 5x minus 3, right? And then I'll divide x cubed by x, right? So x cubed divided by x will give me x squared, right? So I'll put x squared there, and then after getting x squared, I'll take that x squared and multiply by x minus 1. So I'll have x cubed. This will be equals to x cubed plus x squared, right? And then I will take that from my from these values. I'll take that out. Here I'll have minus x cubed plus x squared, right? And then x cubed minus x cubed will give me 0, and then minus x squared minus x squared will give me minus 2x squared, and then I will bring this minus 5x and minus 3 down, right? And then after, I'll divide minus 2x squared by x, right? So minus 2x squared divided by x will give me minus 2x squared divided by x will give me minus 2x. So there I will have minus 2x. And then after having minus 2x, I multiply x plus 1 with minus 2x, right? So this will give me minus 2x squared minus 2x, right? So there I'll have minus 2x squared minus 2x, right? And then minus 2x squared plus 2x squared will be 0. Minus 5x plus 2x will be minus 3x. Minus 3 will come down. Okay, and then now I'll divide minus 3x with x, which will give me minus 3, right? So I'll put that minus 3 up there, and then I'll multiply x plus 1 with minus 3. I'll have minus 3x minus 3, right? And then I'll take that out, minus 3x minus 3, right? And then now minus 3x plus 3x will be 0, minus 3 plus minus 3 will be 0. So therefore, because I don't have any remainder, it means x squared minus 2x minus 3 is also a factor of f of x, right? So now my equation will sort of become like this. Sorry, here I should have x squared minus 2x minus 3 is equals to 0, right? So now I can factorize this part, right? Here I still have minus x plus 1. Here I'll have x minus 3 times x plus 1, right? Is equals to 0. So therefore my x-intercepts will be x is equals to minus 1, and this is twice, right? And then x will also be equals to 3. So yeah, this is how we would find the x-intercept of a cubic polynomial, right? This is how you'd find the x-intercepts, and then y-intercepts, you just let x be 0, and you see what your y-intercept will be minus 3. Okay, and then now we look at stationary points of a cubic function. So stationary points on a graph are points where the gradient of the graph is 0, right? So this is the point where the direction of the curve of the graph changes. On a cubic function, the stationary points are the local maximum or minimum turning points. There are also situations where a point of inflection can also be a stationary point, as indicated in these figures below, right? The turning points are only local because the endpoints of the graph are often greater than the local maximum or less than the local minimum. Okay, so this will be your turning points, and this will be your point of inflection, right? So to calculate these points, the turning points, you will need to calculate the first derivative of x, which is f prime x, and then to calculate the point of inflection, you will need to calculate the second derivative of x, which is f double prime x, right? Njengoba basho lana bathi the derivatives give us the slope of the graph. The slope is the gradient. So to find the coordinates of the turning point of a function f of x, we solve for f prime x equals to 0. Then to find the coordinates of a point of inflection, we find the derivative of the derivative, which is the second derivative, and then we solve for f double prime x equals to 0, right? And then drawing a graph of a cubic function. To draw a graph of a cubic function, you need to find the y-intercept by letting x be 0. And then to find the x-intercepts, you'll need to let y be 0, and then you'll factorize f of x. You'll need to identify one factor by using the factor theorem. Njengoba sesenzile ku example, you need to find one value and then use that value in long division, or if maybe usebenzisa other methods, you can proceed ngendlela ovana uqhubeke ngayo. But then mina I would find one factor and then use that factor as a divisor, and then do a long division method to find the other factors, right? And then after you have your x-intercepts, you can find your turning points by solving f prime x equals to 0. And then yeah, so let us do an example. We need to sketch the graph of let us sketch this graph. Okay, so we need to sketch the graph of f of x equals to x cubed minus 4x minus 11x plus 30, right? So I'll calculate my y-intercept, right? And then to do that, I'll let x be 0, which means I'll need to calculate f of 0. And then if I substitute 0 where I see x, I'll end up with 30, right? So 0, 30 is the coordinate of my y-intercept, right? And then now to find the x-intercept, I will use the factor theorem, right? And then I will sort of like look at the factors of 30 and see which one, if I substitute to f of x, will give me 0, right? So let us sort of like list the factors of 30, right? So I'll have minus 30, minus 15, minus 10, minus 5, minus 3, minus 2, minus 1, right? And then I'll have 30, 15, 10, 5, 3, 2, 1, right? So if I substitute okay, so because it's sort of like time consuming to substitute each and every one of them, I'll go to my calculator and press mode setup, and then I will choose option 3, which is for creating a table. And then I will sort of like have a table for f of x. F of x is equals to x cubed minus 4 x squared minus 11x plus 30, right? And then I will start my function at minus 30 and I'll end it at 30. I'll use a step of 5, and then when I look at the table, I see that f of x is equals to 0 when x is equals to 5, right? So f of x is equals to 0 when f is equals to 5, right? So f of 5 is equals to 0, which implies that x minus 5 is a factor of f of x. Okay, so now I will use this x minus 5 as a divisor, long division method, right? So I'll have x minus 5 divide x cubed minus 4x squared minus 11x plus 30. Yeah? And then after, I'll divide x cubed by x, which will give me x squared, and then I'll multiply x minus 5 with x squared. I'll get x cubed minus 5x squared, right? And then if I subtract, I get 0, I get x squared. Here I'll bring down the 11x and the 50 and the 30, 11x plus 30, and then now I'll divide x squared with x to get x, right? And then I say x minus 5 times x, I'll get x squared minus 5x, right? And then I subtract x squared minus x squared is 0, 11x plus 5, that will be minus 6x, and then I bring down 30, right? And then I divide minus 6x with x, I'll get minus 6, right? And then I take x minus 5 and multiply by minus 6, and I'll have minus 6x, and I'll have plus 30, right? And then I subtract. Minus 6x plus x is 0, 30 minus 30 is 0. So x, to calculate my x-intercepts, I'll use this equation, x squared plus x minus 6 is a factor of f of x, right? Because we have a remainder of 0 there, right? Okay, and then now I can sort of like factorize this second bracket by having x, and then here by having plus 3, and then here by having minus 2, right? So x equals to 5, x equals to minus 3, and x equals to 2. These are the x-intercepts, right? So now I have the x-intercepts. What's next is to find the turning points, right? So now I need to find the turning points. To find the turning points, I will need to calculate f prime x, which is, using the rules of differentiation, is 3x squared minus 8x minus 11, right? And then I will need to solve for f of x equals to 0, f prime x equals to 0, which is 3x squared minus 8x minus 11 equals to 0, right? And then I'll have 3x. Okay, let me just use the quadratic formula. I'll have x equals to minus 8 plus of minus the square root of minus 8 squared minus 4 times 3 times 11 times minus 11, sorry, and then divided by 2 times 3. This is there in your formula sheet, the quadratic formula, right? And then punching my calculator, I get x is equals to, or x is equals to minus 1. Okay, let me quickly punch my calculator. 8 plus 8 squared minus 4 times 3 times minus 11 divided by 2 times 3. I get 11 over 3, which is 3.67, right? Or another x value is, I get minus 1, right? Or x is equals to minus 1, right? So these are the x coordinates of the turning points, right? So now to find the corresponding y values, I'll need to substitute this. So if I say f of 11 over 3, I get, when I just put 11 over 3 in my function, I'll have 11 over 3 cubed minus 4 times 11 over 3 squared minus 11 times 11 over 3 plus 30. I get an answer of minus 400 over 27, which is equals to minus 14.81, right? And then if I substitute minus 1 in my function, I get minus 1 cubed minus 4 times minus 1 squared minus 11 times minus 1 plus 30. I get this to be 36, right? So the points that I have on the graph will be the y-intercepts, x-intercepts, and the turning points. Okay, so if we go ahead and sketch, I'll sort of like highlight these points only. So I'll have minus 3, I'll have minus 1, I'll have, sorry, let me have minus 1 somewhere here, I'll have 2, and then I'll have 11 over 3 somewhere here, and then I'll have 5 somewhere there, right? And then this will be the x-intercept, and then minus 1 corresponds to 36, so I'll have 36 somewhere there, and then my other point will be somewhere there, and then my y-intercept is 30, so I'll have 30 somewhere there, and then x equals to 2 is also x equals to 2 is also there, another coordinate of the x-intercept. So let me sort of like draw 2 somewhere there. Let me have my 2 here. Here I'll have 11 over 3. Here I'll have 5. Right? And then this is another x-intercept. And then 11 over 3 is my turning point. And then it corresponds to minus 14.81. Right? So that will be somewhere there. And then 5 is my x-intercept again. Right? And then what's left now is just to connect the dots, right? So I see with my graph will sort of have this shape. Okay. Right, my cubic function will look like this. Yeah, so when you're sketching a cubic function, it's sort of like the same, the way you would sketch the other functions, such as your quadratic function or other functions. You just need to indicate the critical points, which is your intercepts and the turning points, right? So yeah, okay, so I'll just stop here for now, and then we will continue with cubic functions.